Thank you all for coming today and for taking the time to be with us on this day. My name is Pilar Rosado and I am artist, teacher and researcher at the School of Fine Arts of Barcelona University. In my line of research, I link visual art and artificial intelligence, especially exploring artificial neural networks in the field of photography. In today's presentation, I am going to look at deep learning algorithms used to create the different projects that I will explain. In the context of this society of over-information and big photography production, one of the responsibilities of an artist is to help to give meaning to project purpose into the visual accumulation that confront us. What can we do with such amount of images? We can train algorithms. First of all, let me tell you about the amazing skill that human beings possess. When we look at the world around us, we can immediately understand what we are seeing. So, for instance, here we see several horses, although they are very different. We see in all of them the category horse. But what about machines? What about machine learning and object detection? Just now, the problem of detecting and identifying objects in pictures and videos is pretty much a solved problem. Modern techniques can easily learn to look at specific features like shapes, colors, structures, to be able to detect a horse, a dog, or a person. So, moving on human vision, visual perception occurs in the brain. A human brain has billions of interconnected neurons. An artificial neuron is a mathematical function based on a model of biological neurons, where each neuron takes inputs, weights them separately, sums them up, and passes this sum through a function to produce output. Artificial neural networks are computing systems that emulate the behavior of the human brain, allowing computer programs to recognize patterns and solve problems. But how to input the visual qualities of an image into an artificial neural network? We are usually unfolding images as pixels into neural networks. The value of the color of each pixel is the input for the artificial network. For instance, training an algorithm in an iterative process from a big data set of images containing handwritten numbers from 0 to 9, as you see in the video, the values of the color of each pixel in the input dataset are configuring the weights in the network. This iterative process will converge in a representation of the input dataset, which in this example contains 0, 1, 2, 3, 4, and so on. Convolutional neural networks is a class of artificial neural network most commonly applied to analyze visual imagery. They have become an indispensable tool for everything having to do with image analysis because they are able to detect simple characteristics such as borders, lines, and compose them into characteristics of greater complexity. Convolutional neural networks can be applied in discriminative models used for classification tasks and in generative models used for creation. I can talk about the use of discriminative models in some of my projects. For instance, the first question in my thesis research was to use these computer vision models, which to some extent simulate the initial stages of human visual perception, to help categorize data in large sets of images of artworks by the abstract artist Antoni Tàpies. The images have been analyzed on the basis of their compositional, chromatic, and organizational characteristics without textual notes, so that the analogies found may take us closer to and help us to understand the creator's original values. In addition, the computational system can assist the specialist by establishing analogies between different artists or periods using the same criteria. My project's Mnemosyne and Revolutionary Archive can be understood as a comment to the intellectual work and methods of the art and culture researcher Avi Barbour, and in particular to his Video Atlas Mnemosyne. These photographic installations explore the possibilities of large image datasets extracted from the internet and ordered through convolutional neural networks. These new big images point to the intimate interrelation between the production of images, iconicity, and culture. These large images, made up of thousands of small images, can be seen as an exercise of repositioning Barbour's ideas with 21st century tools, including convolutional neural networks and algorithms such as TSNE, to expand the debate on the notions of visual social heritage and its role in contemporary culture. From this point of view, the projects studied topics such as climate change, COVID-19 pandemic, demonstration around the world. In the context of a society saturated in images, convolutional neural networks constitutes a tool which is of great use for helping us to order visual heritage, in this way offering us a point of access which would otherwise be impossible. Situating our proposal in the field of post-photography, applying models of deep learning for the automated categorizations of large numbers of images, we can give them an order, a beauty, that can show us things never seen before about collective behavior. And about art and generative models, humans are creative and can even turn this deep knowledge that our brain has about what different objects are, for instance, horses, into realistic-looking pictures or beautiful artworks. But if we ask machine learning to produce realistic-looking pretty pictures from scratch without photo camera, turns out that it's a much more challenging problem, because basically, in order to solve that, the machine will have to understand everything completely that is in the picture. The problem is called generative modeling, and you need a good branch of images, a high-performance computer, and a generative algorithm which will be able to give you an infinite amount of similar-looking images. There have been lots of techniques attempting to attack this problem, but by far the most promising one is the technique called generative adversarial networks, or GANs. The main idea in this model is to simultaneously train two artificial neural networks competing against each other. So we essentially have a two-player game. We can imagine that the players are artificial neural networks. Imagine the first player here is a bad guy who wants to create some fake images of the Prado Museum collection. And obviously, the second one is the good guy who wants to prevent that. Initially, these players may be a little silly, so the bad guy might produce something like this. The goal for the bad guy is to fool the good guy the best he can. That's why he presents the good guy a mix of real and fake images. For the good guy in this stage, it's quite easy to tell that this is a fake. But now, suppose somehow the good guy was able to explain the bad guy exactly how he came to this conclusion. Then the bad guy can use that information to up their game and produce something much more convincing. This interaction forced to improve both themselves. Then the bad guy can use that information. The idea is that if we continue this iterative process long enough, we talk about high-performance computer working during 15 days or 1 month. It depends on the data set. Both players will evolve to the point where the fakes are indistinguishable from the real images. The bad guy is called the generator network. Its job is to take a bunch of random numbers and turn them into some kind of a picture. Then we have the discriminator network, whose job is to look at our pictures and be able to classify them as are they real or fakes. Sorry. Joan Fontcubert and I have applied GAN technology to produce fake images in our prosopagnosia project. Prosopagnosia is a complaint that affects perception and memory, so that it's difficult or impossible to recognize faces. The project began with the creation and publication of a photo book under the same title that consists of a 7 meters long leporello. On the recto side are original portraits of people who were well known in the 1920s, found in the files of journalist Alfonso Bonet from the daily paper La Prensa in Spain. It consists of a curious collection of a very varied newspaper cuttings which they used when they had to publish an article about some celebrity. On the verso side appears a sequence of portraits generated from these photographs by means of the GAN. The book captures the wonderful sequence of learning of the computer. It starts by generating images with the pixels ordered at random, but little by little the system discovers the patterns associated with the faces and improves the creation until it obtains photographically convincing images of people who never existed. Establishing an analogy with the morphogenesis of a living being, observing the filed images produced evokes for us important steps in the history of art, such as expressionism, cubism, surrealism, or abstraction. In the 19th century, in the context of the social science, eugenics emerged, a discipline that today we consider ideologically reprehensible, but which promote valuable advances in prediction techniques. The work material of eugenics was the anthropometric datasheets and photographies. Basically, the method consisted of collecting large amounts of data from which regularities were extracted. Regularity defined what was normal, which was considered good and correct, as opposed to exceptions, which would correspond to monstrosities or deviations. The path was started by Galton, and Cesare Lombroso in Italy and Alphonse Bertillon in France continued. Bertillonism was implemented in the police forces of many countries as forensic procedure of documentation and prospecting, consisted of fragmenting faces into their essential components, forehead, eyebrows, eyes, nose, and so on, to make the so-called physiognomic atlases. By combining pieces of each category according to a simple rule of the game, that is, respecting the layout of the facial structure, the result will bring us closer to the infinite of possible faces. The GAN was trained with the albums of Alphonse Bertillon. The slider shows a synthesis of the training sequence of the GAN. The GAN has not only generated convincingly photorealistic faces, but has done so by mimicking the graphic patina of the originals as well. As a critical parody of the arrogance of this predictive methodology, we have made the eugenics series within the prosopagnosia project. Since the later third of the 19th century, the production of photographic files of the mentally ill has been part of an approach to study and classify the characteristic features of the mental disorders. In the 1940s, the Barcelona psychiatrist and humanist Joan Obiols took hundreds of photographic portraits of the patients he visited at the psychiatric hospitals. Obiols was pioneer in the country in the use of artistic creation as a tool for psychotherapy, at the same time as Jean Dubuffet popularized Art Brut. GAN technology has been applied to the archive of Dr. Obiols. On its learning journey, artificial intelligence develops a laborious morphogenesis in which we will seem to recognize classical aesthetic models as Kirchner, Kokoschka, Picasso, Bacon, among others. But here, even more so, discrimination under the umbrella of madness invites us to question the identity patterns of normality. In the project La Petit Mort, exploring the limit of how far human expressions can be captured, we have put GANs to the test using a collection of portraits of people whose portraits were taken during an orgasm, mixed with portraits of dead people who died of violent causes. After training, the GAN generates artificial portraits in which it's capable of capturing the essence of the expression of the subjects. Many of them with closed eyes, their mouths half open. The GAN latent space allows to generate new hybrid predictions, speculations regarding genders and categories. Words are often insufficient to give a precise explanation of certain concepts. For example, the word orgasm describes the sudden discharge of the tension built up during the cycle of sexual response. For some people, increase their blood pressure and heartbeat produce an effort of such magnitude that they may even lose consciousness for a brief period of time. The French language has an expression to describe such experience for which the term orgasm is no longer sufficient, la petite mort. This French expression attempts to overcome the limitation of language in referring to a specific state in which the concepts of death and orgasm are indeed so close as to be almost indistinguishable. Finally, we have to talk about the installation that Joan Fontcubert and I presented at the KIC Festival, titled Beautiful Agony. For us, orgasm represents a possible starting point to move between the public and private spheres, between the erotic and the political. From a data set of faces experiencing orgasm extracted from the webpage beautiful.com, in which thousands of users can upload their video selfie, having affirmed that their orgasm is genuine and not fake, generative neural network technology is once again used to automatically create a progressive sequence of portraits of non-existing people in the moment of experiencing ecstasy. This technology has been deliberately applied in a caricatured way to a certain category, that of powerful figures in the political sphere who have been involved in cases such as sexual scandal or illicit relationships. In this case, we choose Donald Trump, Silvio Berlusconi, Juan Carlos de Bourbon, and Dominique Strauss-Kahn are the protagonists of memorable examples of abuse of power and sexist violence encouraged by patriarchal society. Deepfake media is now capable of a high degree of refinement that disguises the manipulation and make it indistinguishable. However, in this art world, the artist has opted for grotesque exaggeration and parody, which creates a fiction that does not seek to deceive, but rather to reveal the mechanism of deception. Sorry. The installation is completed by 3D snapshots that correspond to the 4 figures, bust with petrified faces, as if the eye of Medusa, the eye of history that shows up shame, had caught them in the epiphany of ecstasy. The project Déjà-vu applies GAN technology to a dataset composed of all the works belonging to the collection of the Prado Museum in Spain. Images from landscapes, still lifes, portraits. Ever since their conception, GANs have raised a lot of interest in the academia, mainly because the quality of results that they produce is much better than in any other competing approaches. In the Déjà-vu project, we have trained a GAN about 7,000 images from the collection of the Prado Museum in Madrid. It's important to note that none of these generated images are the same as the real ones. The generator is essentially combining, mixing, and matching different features of images in the collection in novel ways based on random inputs. We want to remark that with GANs, artificial intelligence learns to imagine. Most of the categories in the Prado Museum collection are extremely hard for an algorithm. Nevertheless, we can see that the generator is doing a good work looking at portraits, landscapes, still lifes, architectures. We have relatively realistic looking images, although the number of photographs of each category that the collection has is limited to train a GAN. Basically, whatever happens to be in the training data, the generator will have to replicate one way or another. For example, we can see in these images that the algorithm has problems with hands, but it will do its best to reproduce them. Some images, we could say, that show the monstrosities that arise from the machine subconscious. That is pretty funny, is that the generator itself is a continuous function, so we can basically see each generated image as a point in the high-dimensional latent space, the space of the generator. And if we have 2 such points, we can imagine interpolating between, just traveling from one to the other, because it's continuous. The changes are kind of natural. Not all the pictures are perfect, but the overall quality is surprisingly high. It's interesting too, the variation of the images are produced by the same network, and we can morph between any of them. In the exhibition of the project Déjà-vu, you can also see 6 videos that show the latent space generated from the Prado Museum collection. After the training process, the final question is evaluating the results. In computer science, the answer is the best is the one is closer to the training set. But in art, if we focus on learning for perfection, we will miss other interesting outcomes for artistic creation processes. We highlight creative interest for suboptimal solutions rather than perfect reproductions in pursuit of the artistic concept. Recently, new IA systems have been designed, DALI 2, Midjourney, Crayon, that can create realistic images from a description in natural language. This system have learned the relationship between images and the text used to describe them. They can combine concepts, attributes, and styles. Also, they can take an image and create different variations of it inspired by the original. On the slide, you can see 3 images generated by Dalí. From the description, a photorealistic painting of Francisco de Goya with a queen sitting on a throne and a dog lying at her feet. And on this slide, you can see 3 images generated from the description, a painting depicting a landscape. It belongs to the Prado Museum collection, and it's painted by Francisco de Goya. In the painting, there is a lake, a house, and a sky full of clouds. To sum up, we can say that in a non-supervised manner, GANs are capable of extracting relevant patterns from our collection. This aspect of automatic learning is in fact something new in the history of computer art, a computer that is capable of on its own of learning the structure of the world. But GANs models are not completely autonomous creative systems. They are not able to formulate an intention and assess their own results. The dataset the GAN is trained on is the key to its creativity. Certainly, from the perspective of artistic creation, the application of GAN technology opens up new formal and conceptual imagery. With the methods and technologies recently developed, human beings are now able to build machines that can paint, write paragraphs, compose music, develop winning strategies in complex games. This is the beginning of a generative revolution that opens up numerous questions about the mechanism of creation and ultimately about what it means to be human. Images generated by artificial intelligence are a cutting-edge research. Although recognizing creativity in machines or in humans is not a simple task, for some years now, several authors are studying the way in which artificial intelligence can help us to understand and explain creativity in humans. Our challenge is establishing bridges between generative deep learning and art. This process questions the notion of artist and curator, but the most interesting thing are the errors of the system itself, the failed test, the intermediate steps, and the technological unconscious that emerge from accidents. This desacralizes the paradigm of creativity and art. Can we only imitate previous gestures, never originals? To a certain extent, everything is a déjà vu. Thank you very much for your attention.